Hello everyone! Here, we present a new tutorial for the brand new AI board from System Electronics, Astrial. In this tutorial, we present how to use different carrier boards to let you understand that Astrial is compatible with a plethora of hardware already on the market. Let's get an RGB LED blink on several carrier I/Os. Material used in this project: one Astrial board, 3 different CM4I/O waveshare carriers, the base A board, the base B board, and finally the PoE board. As in the RGB LED tutorial, the one with Raspberry carrier, we need 4 wire jumpers, the breadboard, and again 3 220 ohm resistors. Please don't forget that we can also use a PoE injector to power the PoE carrier. And last but not least, the RGB LED. Here is how to set up the hardware. First of all, connect the Astrial's ground to any CM4's ground pin and Astrial's VCC to any CM4's 5V pin. For this tutorial, we have used pins 2 and 6 as 5V and GND respectively. Second, connect the RGB LED. Connect the LED's ground pin, the longest pin, to any Astrial's ground pin. For this tutorial, we have used pin 20. Connect the red, green, and blue pins of the LED to pins 22, 18, and 16, corresponding to GPIOs 25, 24, and 23 respectively. Here comes the software part. First, connect to your Astrial board using SSH. Replace the IP address with the IP address of your device. Alternatively, you can use Astrial directly with a keyboard and mouse with an HDMI monitor. Now that we're connected to our Astrial, let's install the GPIO library using pip3. With the library installed, we have to write the Python script to control the RGB LED. I am going to use Nano, but you can use whichever editor you want. Here, we need to import all libraries we need. So we import time for handling delays, and GPIO for GPIO control. Next, we'll define the GPIO lines corresponding to the RGB LED. We decide to use line numbers 3, 2, and 1 for red, green, and blue respectively. We also need to specify the GPIO device we'll be using. In this case, it's /dev/GPIO chip 1. In the GitHub repository, you can find the full list of available GPIOs you can use. Before we proceed, let's ensure that the GPIO device is valid by using an assertion. Now, we'll request control over the GPIO lines with initial settings. We'll configure each line as an output and initially set them to inactive. Within this block, we create an infinite loop to blink each color of the RGB LED sequentially. We turn on each color for 0.5 seconds and then turn it off, before moving to the next color. We've completed our script. Let's save the file and exit the editor. Now run the script and yay! The RGB LED blinks.